if we're going to play around with the weights here. Let's look at another one. We're going to create a lattice plot, a lattice graph. It's not a lattice plot, a lattice graph. And we're going to assign random weights to the edges, and then we're going to color the ones based on the weight assignment. Okay, so this graph lattice has nothing to do with the lattice package. This is a function in iGraph itself. So this is a 10 by 10 lattice graph, and you can understand why it's called that. Looks like a lattice, 10 rows, 10 to a side. Okay, and then we're going to assign random weights to the edges using a uniform function. I see your question there. I'll get right to you. Uniform function, and then we're going to use a starting color of gray for everything, for all of the edges. And if we plot it, let's plot it and zoom it. Okay, so that's our base graph, our starting graph. And now we're going to color the edges red if they have a weight that's higher than 0.9. So let's zoom it. And you can see some. Okay, when we use the uniform, the uniform family of the random variable, you'll get values that are less than 1, somewhere between 0 and 1. So a very small percentage of them, actually, somewhere around 10% of all of the edges should have a value greater than 0.9, and you can see them. Comment, what color is an edge between a red and a black node? In the previous one, I don't remember. Let's see. It colored edges joining the red nodes in red and edges joining. So an edge between a red node and a black node was gray. Let's do it again. We didn't have many red nodes. The only edges that are between two red nodes are red, and only edges between black nodes are black. So an edge between a red and a black should be gray, if I understand this correctly. Oh, okay, so now we've got a good mix. It'll be more evident. It's randomly coloring them. So the last time we only had 2 red nodes, so we couldn't really see what was supposed to happen. So now we make them all gray. So everything, all of the edges are gray. It's kind of an optical illusion. Your eye will play tricks on you. This one, to me, looking at it close up, almost looks kind of reddish because of the 2 large red circles on either side. So now we're just making that variable red. That's all it is. It doesn't make any change. Make a variable black, BL, doesn't make any change. But here, this should make edges joining 2 red nodes red and make edges joining 2 black nodes black, and everything else should still be gray. Okay, so there we got now you can see it more clearly. In fact, in the first example, I don't think we had, the 2 red nodes weren't connected, but now you can see it more clearly, right? Black, 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 red, gray. Okay, here's a couple demos of what happens, different ways to visualize graphs. And so take a look at this. There's an ER graph with no labels, and the vertex size is set to 3. Here's a WS graph, and you can see the distinctive shape around the perimeter. And This is Barabasi. And again, you can see the, again, with small vertices and no labels. So how do you affect the labels or the names of the vertices? Well, one way to do that is with vertex label. And in fact, if you want to get a very fast cheat sheet on all of the possible parameters and values, this iGraph.plotting function, calling it in help, it's a very complete listing of all of the parameters: size, color, frame color, shape, label, so forth and so on. Okay, so let's play around with the attributes a little bit. The attributes of the edges. So here is another lattice graph. Take a look at it. And again, we're going to assign weights to the edges from a uniform distribution. We're going to make sure that all of the edges are gray. And now, again, we will turn them red if they have a weight greater than 90. And we just did that a second ago. Okay, so let's continue. But now we're going to change the layout. We're going to take these same attributes, and we're going to display them with a Kamada Kawai layout. And where the intersections are nodes, it's the same plot that we had a second ago, except now the nodes are just represented by the intersections, and the edges, you can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 red out of how many ever there are. Those were the edges that had a weight of greater than 9.